Hello guys, welcome to Anatomy and Physiology screencast. Tonight's topic is going to be vascular system. We have got 4 key objectives to look through. The better you do these core now notes, the more successful tomorrow's lesson is going to be. So I'd appreciate it if you really did make a good effort on these. So first one, we're looking at how you explain oxygen and carbon dioxide transport in the blood. So how does it move around the body? Well, it's very simple. There's a formula for this. Hemoglobin's the main carrier. The secondary carrier is plasma. So if I just quickly went on to that and explain that, if you look down here, so you've got oxygen transport, oxygen binds with hemoglobin to form oxyhemoglobin, then it's also carried in plasma. Carbon dioxide follows exactly the same formula, so it firstly combines with hemoglobin to form carbon monohemoglobin. That's the spelling for it. I know that's quite tough. It's also carried in plasma, which is identical as this, and there is a final way, there's an extra way you can put for carbon dioxide. It's also carried as carbonic acid. Okay, so there's your first objective complete. Okay, right, next objective then. Explain the effect of smoking on oxygen transport. Popular exam question that hasn't come up for a long time. So basically we've said that oxygen is carried via hemoglobin. So what we need to do is look at what is the difference when people smoke. So when you smoke, basically carbon monoxide is produced. Okay, so carbon monoxide basically becomes way more attractive to oxygen than hemoglobin. So the word attractiveness in physiology is called affinity. So if you look at what's saying here, so when you smoke, carbon monoxide is produced. Resultantly, oxygen has a higher affinity for carbon monoxide than hemoglobin. This then means that the relationship or the combination between oxygen and hemoglobin is reduced. So that is known in physiological terms as reduced oxygen-hemoglobin association. And of course, the net effect of this is that there's a decreased oxygen diffused into the working muscles, which means we can work aerobically with less efficiency. Okay, so it decreases our aerobic performance if you want to add that to that section there. Okay, so moving on to objective 3 then, mechanisms to maintain venous return. Now we've looked at venous return in quite a little bit of depth in the kind of under the roots of a intrinsic control of heart rate, cardiac output, stroke volume. So we've talked about that concept that in order to increase our stroke volume and cardiac output, we need to increase venous return, and that is known as intrinsic control. Venous return, okay, in order to be effective, needs certain mechanisms to help maintain it, because basically if you remember, venous return was that kind of deoxygenated blood returning to the heart. Now because it's deoxygenated blood and it's returning to the heart, it's doing so through veins, okay, and also it's doing so through very low pressure. So there needs to be certain things within the veins that it's returning to the heart that need to be there in order to make it effective. So first one, you have something called a muscle pump, and this basically involves skeletal muscles squeezing within your body, so kind of any kind of muscles around your legs, for example, if you're running, squeeze together and force the blood back towards the heart. You then have gravity, so any blood from above the heart will be pushed back down towards the heart. Smooth muscle, so these are located in the walls of the veins, okay, and they help then squeeze the blood back towards the heart. Pocket valves, these are located in the veins and they prevent a backflow of blood. Finally, you have respiratory pumps, so when the pressure in the thorax changes, it causes veins to squeeze blood back towards the heart. Okay, and going on to your last topic then, so as I said, we're talking about a vascular system. I probably should explain at the start, the vascular system basically refers to anything to do with vessels and blood. Okay, so what we're going to look at then, what are the effects of a warm-up and a cool down on the vascular system? So basically then, the key thing when a warm-up question comes up on a vascular system is that you remember that the vascular begins with V, because the V is going to be the memory link to allow us to remember a variety of things. So if I said to you vascular system refers to vessels, what we need to understand is what happens to the vessels that are supplying our muscles during exercise. So starting off, there are vasodilation, remember that key term for widening of arterioles and precapillary sphincter supplying working muscles, and then conversely you've also got vasoconstriction of the arterioles and precapillary sphincters supplying the non-essential organs. So this should be very familiar from when you did your lesson on redistribution of cardiac output. Then You also have an increase in vascular shunt. So you've basically got increased blood flow, stroke volume, cardiac output, whichever way you want to put it, as a result of warming up. Finally, you increase them, well, not finally, but ultimately, you increase venous return. So because you're warming up and you're actually running, jogging, and doing something prior to exercise, it means you get more blood back to your heart via Starling's law. Then you've got a viscosity of blood is decreased. Now what that means is the kind of resistance to blood flow is lowered because the blood becomes thinner. Now you're not allowed to use the word blood becomes thinner. You have to use there's a decrease in blood viscosity. Like we talked about a decrease in muscle viscosity. There was never any time in ASPE, you will talk about the increase in viscosity of either the blood, muscles, anything. It always decreases, so it becomes either more pliable as a muscle, it becomes thinner, so it's easy to flow through the arterioles, sphincters, arteries, veins when exercising. And finally, the key thing behind, if you warm up, the word warm should tell you that your blood temperature is going to be increased. Okay, so you have an increase in blood temperature, and that basically is the kind of prerequisite for all of these things to happen here. So they're the key things. A lot of V's. You're probably going to get your marks from the V's here. So remember, vascular equals vessels and blood. So we're talking quickly about vessel width, blood flow, and thickness or kind of resistance value of blood. Okay, thank you very much.